So can someone give me some examples of where loops can be applied, or what is their necessity? Some real life examples. Raise your hand and just give one example at least where loops may be applicable. Yeah, you wanted to say something? Just, you know all this already. Where do you find loops useful? Not loops as in coding, like repetition. Huh? Escalator. Okay. So what is the loop concept there? It's going one floor after another, or what is the other concept there? Huh? What will be repeating? Lines. What lines? Okay, escalator is one example. Their loop can be thought of in two ways. One is, say if we are in ground floor and if we press say 10th floor button, until you reach 10th floor, it will keep going to the next floor and next floor and next floor and so on until it reaches the 10th floor, and then it stops. There may be many floors above, but it stops at 10th floor. Okay, that is one thing. Other concept of loop here is, this process will go on continuously. Okay, someone pressed 10th floor, it went to 10th floor. Then it is waiting for the next input. Someone will press some other floor number, it will go to that floor. Again, it waits for the next input. Someone will press another floor number, it goes to that floor, right? So this again is a loop. All right, so it's like a loop within a loop. Within one input, it will go across floors. So that is a loop. But then the fact that it is waiting for one input after another, that is another loop. Okay, good. Another example? Yeah. Right. Yes. Simple, good example. Loop video. The entire video is played once. Again, it starts from the beginning. Again, it's played. Again, it starts from the beginning. Again, it's played. So until you stop, it will keep going on. Yeah. ATM machine. Yes. Good example. So what is the loop there? Yeah. Again, here there are two loops. For the same person, if say it sends an OTP or it expects you to enter a PIN, right? If your PIN is wrong, it gives you another chance until you enter the right PIN. So that is a loop. Another thing is, now for different people, so one card transaction is over, next person comes and inserts a card, again new transaction, again within that new loop. If the PIN is entered wrong, again next chance, and so on. So that is a loop. Yeah. Okay. Sine wave. It's, you can simulate a sine wave using a loop. Yes. Fine. So that is a little complicated. Okay, fine. So we have many real life examples where we have loops. Another, uh, some other examples are like, say if you are given a text file, you want to count the number of lines in that file, or you want to count the number of words in that file, or number of characters in that file. That is a loop. Like, you go through character by character and keep increasing the count, or you go through word by word and keep increasing the count, or you go through line by line and keep increasing the count until you reach the end of the file. That is an example of a loop. Or particularly in Excel sheet, you see loops many times. For instance, say if I want to generate some 100 numbers, right? One way is I write myself 1 2 3 4 and so on. Another simpler way is I just type 1, okay, and then I drag it. You see, now it generated all these numbers on its own, 1 2 3 4 and so on. So just by simple dragging, I could generate the subsequent numbers. I could extend this until 100, 1000, million, whatever it is. So basically it is using a loop. Okay, so here what is the loop? If you are in the next cell, add 1 to the previous cell and put the new number in the current cell. Okay, so that same thing, it will repeat as long as you drag it. Okay, so if you are in cell 1, it is 1. When you are in cell 2, it is adding 1 to the previous number and entering it. If you are in cell 3, it is adding 1 to the previous number, that is 2, and entering it. Okay, filling it with that data. All right, so that is a loop. So here it is going in a loop as long as you wish it to go. All right, fine. Another example is like sorting, right? Like this set of numbers, suppose if they were not in sorted order, if I had to sort them, I had to loop through this entire array of numbers. Okay, and then I have to make some modifications. So there are various kinds of sorts which you will learn in data structures. We could have learned them in this course, but there is not sufficient time. So you will learn some of them in data structures course, like insertion sort, selection sort, bubble sort, many kinds of sorts are there. Okay, so many places you use loops, you need repetition. Fine. Other many numerical examples, mathematical examples, like say for instance, given a range of numbers, within this range of numbers, how many prime numbers are there? To find that, you need to check every number and then see whether it's a prime number or not, and then every time you see a prime number, increase the count by 1, right? So maybe between 1 to 100, there may be some 10 prime numbers or 17 prime numbers, whatever they are, right? So to count this, you need to go through each number. Now I can increase my range. I can increase it from 1 to million. So you are looping one number after another, you're checking. Okay. Or like within this classroom, how many students are there? I have to go to each chair and then count which chair is empty, which chair is non-empty. If the chair is non-empty, I increase the count by 1, and by the end of scanning, I get a count. Or within the classroom, how many boys are there, how many girls are there? Or within the range of numbers, how many even numbers are there, how many odd numbers are there, how many prime numbers are there? Or what are the factors of a number, right? How many factors does a number have? And what is the sum of these factors? Is it equal to the number or is it not equal to the number? That will help us in understanding whether it is a perfect number or not. Or given the number, how many digits does this number have, right? If it, usually we deal with small numbers, but imagine there is a number which fills 3 pages in a book. You can't count it so easily, right? So imagine if a very large number is given to a computer. For it to count, again, it has to loop through each digit. Okay, one digit, then next digit, then next digit, and so on. It keeps increasing the count, right? So again, there looping is there. Fine. So these are all examples of looping. And so in C, how many kinds of loops are there? Do you know? Huh? 3, right? So while loop, do while, and for loop. Okay. So if you look at while loop, the syntax is some expression or condition. So while this condition is true, you execute some block of statements. I hope you know that this indicates multi-line comments, right? Slash, star, some text, again, star, slash. This indicates multi-line comments. And single line comment is indicated using 2 slashes. Okay, this will comment only the current line. But if you have many lines to comment, you use forward slash star and again star forward slash. Okay, so this is the comment style in C program. In other languages, you have different symbols to comment. In Python, it is hash, right? Similarly, in other languages, you have different symbols, but in C, double slash is for single line comment and this for multi-line comments. Okay. So this while expression condition, or while some condition is true, you perform something. This is nothing but if else condition done repetitively. That's all, right? So for instance, if I want to check if a number is even or not, right? So what do? If I say if n mod 2 equal to 0, I say print even, else I'll come out. Let's not worry about the else condition right now. I just want to know if a number is even. Okay. Now this will work only for a single n. All right. Now suppose I want to write a program where the user gives an input saying he just gives a number as an input. Okay. Now my program will tell him every time he gives me a number, it will tell him whether it's even or not. Okay. So now it works not just for one number, but any number of numbers. Fine. You got it? So basically this if else thing, if else works only once. Now the same thing, if I put in a loop, okay, that is like while. So here, rather than if, I write while. Okay, while n mod 2 equal to 0, print even. Fine, you are repeating that if else thing again and again. So if n mod 2 equal to 0, print even, again comment check. So here, now let's assume we are writing such a program. Okay, now before I code that program, let me write its pseudocode. Okay, so pseudocode means it is not pure natural language. At the same time, it is not pure complete program syntax. It is somewhere in between. All right. So first step, I read n. All right. Second step, let's write just if else code for now. If n is even, print even. Okay. It's as simple as that. Now, if I have to convert it to a loop, okay, what should I do? Can someone tell me how do I modify this pseudocode? Right. So I add another step which says go to step 1. That's it. This will convert this to a loop. Now again you go to step 1, you read a new n, you check if it is even, print even. Now again you go to step 1, again check if it is even, read n, check if it is even. If yes, print even. That's it. So just by adding this third step, you created a loop. Okay. So pseudocode helps you to understand the structure of the code more clearly and cleanly before you get into coding. All right. It makes your life simpler. Okay. So while loop has a structure. Okay. So let me. So this is the simple flowchart of while loop. All right, you have an expression, test expression, like you test whether this expression is true. If it is true, you enter the loop body and you execute those statements. All right. Now, up to here, only this portion, if you consider only this portion, it is nothing but an if else statement. Okay. So what distinguishes if else from while loop? This loop. That's all. So you come back to this test expression. If it is true, you enter the body of the loop. Again, you come back to test the expression. If it is true, you enter the body of the loop. So this you continue until the expression is true. The moment you see the expression to be false, you come out of the loop and execute the statement immediately outside the loop. That's all. So basically, while loop or do while or for loop are nothing but an if else condition put in a loop. Like a YouTube video is played in a loop. If else condition, if you play in a loop with different inputs each time, that becomes a loop, while or do while or for. That's all. Okay. Now, so let's just code this while loop. It's always a good habit to open the brackets in the same line, right? Rather than opening this opening bracket in the next line, make it a habit to open it in the same line, so that you don't make mistakes of putting a semicolon here and then opening the bracket. Okay. I already gave you an example of what happens if you put a semicolon after if condition immediately, right? It's there in the previous lecture notes also. Similarly, students make a mistake of putting semicolon immediately after the while condition or after the for condition. That is not an error technically, but that will make your program behave erratically in an unexpected way. We'll see if we get time. I'll explain it now, or in the tutorial it will be explained. Okay, so just 3 steps. I want to scan an integer, right? So scanf ampersand n, and normally what in if else I just see if n mod 2 equal to 0, printf percentage d is an even number, that is n. Okay, this is simple. Okay, so let me just run this. I enter 4. It says 4 is an even number. Fine. Now, if I have to test again and again, what I need to do is I myself need to run this program again and again. Okay, I run it again. I enter some other number 12. I run it again. I enter some other number 13. It's not printing anything, which means it's not an even number, right? So I enter this. I run this code myself in a loop, but I want to put this loop inside the code. Okay, so what do I do? Instead of if condition here, I write while. Okay, now will this work? Yes. Okay, let's see. Not, it's going in an infinite loop. Why? Can someone tell me? Huh? Yeah, why is it printing the same statement again in loop? Because the value of n is same. Initially, you gave n to be 4. It checked if 4 is an even number. It enters the loop. Now it is printing. Now what it does, it goes back and checks again if 4 is an even number. It's true. It will enter the loop. It will print. Again, it goes back. It checks if 4 is an even number. That's it. It goes on in this loop indefinitely because n is not being updated. N is always 4. So how do you update n? How do you ensure that you read and print, read and print? No, if you break, you just break. It's like if else only, right? Right. So now you need to put both the statements in the loop, reading and printing. Right? So what do I do? Should I remove it here and put it here? Where should I put? Above printf or below printf? Above printf. Okay. Now will this work? Huh? What is the problem here? Yeah, n is not initialized. So how does it enter the loop? It may enter because n may have some arbitrary value, but that n is not what we intend to. So now what to do? So we have one scanf outside while loop and one scanf inside while loop. This will work. Scanf now should be below printf. Why? Because the first time you already scanned once and now it will enter the while loop. Now it will print. Now you scan inside the loop. Now it will keep printing and scanning inside the while loop. Okay. Now, how do I stop this? The program is forever expecting an input. When you don't give, it just waits for the input forever. If I don't give an input, how do I say I don't want to give an input? Or how do I stop this? Yeah, if you give an odd number, it will stop. That's it. It will come out of the loop. Okay, but this is not technically correct way of doing it because you don't know what kind of number you're going to give, right? So you should have some specific marker to tell the computer stop here. All right. So yeah, we'll come to that. That is another way of stopping it. That is a different scenario, right? Here the scenario is I just want a code which tells me whether the input is an even number or not. Okay, I don't want to limit. I don't know beforehand how many numbers I want to test, right? So I can do that if I want. Say only 10 numbers I want to test. I can say, okay, I have a counter. Increment, start this counter from 1 until it goes to 10. Keep increasing it one at a time. And every time you give a number and tell whether it's even or not. Okay, that's a different thing. But suppose I don't know how many times I want to check. Then I can't give a counter. Okay, I can only give a terminating marker. Like when I input this, you stop. Okay, suppose I want to change my program to something like, given a character, I want it to print me its ASCII value, right? Sometimes you may not have the chart with you. You just want to write the code so that when I input this character, the computer should give me the ASCII value. Fine. So let's modify it. So rather than int n, I'll say char ch. Now, should I scan %b or %c and ampersand ch? Okay. I hope by now you understood that variable name need not be of a single character. Okay, just because we are using examples of variables with single character does not mean variable should be only of single character. It can be a word, it can be a long string, but it should not have spaces in between. Okay. So now what I want to do, I want to enter, every time I enter a character, I want it to print me its ASCII value. Okay. When do I want to stop? Suppose I choose some special character. When I enter the special character, it should not print ASCII value, but it should just stop. Fine. Let's assume for now, say that character is Q, like quit. When I enter Q, I don't want its ASCII value. You just quit. Fine. So now what should I do? Very good. While ch is not equal to q, you scan the character. Okay, but before that we need to put the printf statement because we scanned the character. Now we are checking if it is q or not. If it is not q, it will enter the loop and it will print its ASCII value. So how do I print the ASCII value of a character? %b, that will give me its ASCII value. Okay, %b \n ch. All right, and again I scan the next character. Fine, this should work. First I gave a character, it will check whether that character is q or not. If it is q, it will not enter the loop. If it is not q, it will enter the loop and it will print its ASCII value. Now it is waiting for next character. It takes that character and it will check if it is q. If it is not q, it will enter the loop. Okay, so it will repeat this process. So it is only, these are, okay, somewhere I missed a semicolon. Opening bracket. Okay. Yeah. So suppose I entered, say, G, printing 103, and then it's also printing 10. We'll see what that is. F is 102, A is 97, B is 98, and so on. R is 114, and so on. Now, if I enter Q, it stops. Okay. Can someone tell me why it is printing 10? Huh? Exactly. Very good. What's your name? Huh? Kumar. Okay. So he got it. It is taking enter button also as a character and it is printing its ASCII value also. Okay. You are entering G and then enter button. G is a character, enter button is a character. Enter button's ASCII value is 10. Okay, so G's ASCII value is 103, enter button's ASCII value is 10. Again, F ASCII value is 102, again you're pressing enter immediately. Its ASCII value is 10. So every time you are pressing enter, it's taking that character also and also printing its ASCII value. Now, how do I stop this? In CH, enter is also an input for it. Yes, it has to be stored. It is storing. Okay, you for let me make it clear to you. Suppose if I say F G H J I, you see it's printing everything together. So if I print F enter, it is printing everything. It's like two characters you are entering. That's all. Fine. So now I say Q, it quit. Now what to do? Okay, so scanf, it has much more than what you know about it so far. You see, in scanf also, you can give sort of delimiters. When you give an input, you can also specify, if you give more than one input, you can also specify how these inputs should be separated. Fine. Now, suppose if I enter 2 or 3 numbers, you would have done these programs already. If I want to enter 2 numbers and just print them, right? So let me just comment this part. So suppose I say, I declare int ABC. Let me say 3 numbers. Now I scan these 3. How do I write that? I just write %d, 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 right? And then ampersand A, ampersand B, ampersand C. And then I print. Suppose I print them with space and a new line at the end, no ampersands. All right, this is fine. So let's just run this. It's just a warning, CH is not used, that's okay. So suppose I say 3, 4, 5. It will print 3, 4, 5. Fine. Now the same 3, 4, 5 I can enter in different lines also. 3, then 4, then 5. That's also fine. All right. Now what if I enter 3, no, anything you can enter. You can enter 5, 6, 7 or 5, 6, 20, whatever it is you can enter. That's fine. Huh? Yeah, 20 is 2 characters, no? So you can give a long number also. This is one number, this is another number, this is another number. It's not reading characters, now it's reading integers. Okay, so how is it separating integers? Through space or new line. Fine. Now suppose I try to separate these integers with commas. So 3, 4, 5. Let's see what happens. Something weird. Why? Because it is expecting 3 integers either separated by spaces or new lines, but not some other delimiter. Here comma is a delimiter which it is not expecting. Okay, but you can change your code so that you know you are going to separate your inputs with commas. Then what to do? Here you need to specify that %d comma, %d comma, %d. Okay, now you have to give commas, you can't give spaces or new lines. You have to separate them using this separator only. Fine. Now let's see. So 3, 4, 5, it read them properly and it printed them properly. If I input them with spaces, 3, 4, 5, again some error. Okay, so what happens is, what scanf is doing is, it is expecting an integer and then a comma, an integer and then a comma and then an integer. Okay, if it gets an integer, it reads and stores it in the variable A. And if it gets a comma, it just reads and discards it. It waits for the next integer. It is matching comma with the comma which you have put in the scanf statement. Okay, if it matches, it just reads it and discards it and goes to the next %d. Now once it gets again an integer, it stores it in B. Now it waits for a comma. If it gets a comma, it reads and then just skips it, goes to read C. That's fine. But instead of comma, if it is getting space, it does not know whether to match the space with, first of all, it should not get a space. It's expecting comma. So now what happens? The moment it is getting an unexpected input, it stops reading. So when you give comma in place of space or space in place of comma, the scanf will stop reading. Whatever it read so far, it read only that. So for you to know how much it has read, you can now store the return value of scanf in some variable and see how much it has read. So let me create another variable count, and let's say count equal to this, and then let's also say let's also print count here. So count means how many inputs scanf has read. Okay, if the inputs are given according to the expected format, scanf reads 3 inputs, so count should be 3. If in between you give anything unexpected, in place of comma you give space, in place of space you give comma, it reads only the inputs up to the expected input. So let's see. I gave commas, right? So 3, 4, 5. 3 inputs properly I'm giving, so count should be 3. Okay, 3, 4, 5, 3. Fine. Now suppose instead of comma I give space. Suppose I give comma first time and then space second time. So now how many inputs should it read properly? 2. You see, it read 3 and 4. C is some arbitrary number. It read only 2 inputs, so it printed 2. Fine. C, every time you declare a variable, some value will be there, some arbitrary value. Okay. So if you if you initialize a variable either by directly assigning a value to it or by reading something and storing it using scanf, then that variable's arbitrary value is overridden with the value which you have entered. Otherwise, whatever arbitrary value that variable was created with, that value will be there. So basically what it means is scanf read first 2 values and stored them in A and B. Since it has seen space instead of comma, it stopped reading. Now it did not read C. So whatever was already there in C, when you declared int ABC, that value is printed now. And scanf read only 2 values, so it printed 2 at the end. Count is 2. Okay. So delimiter. This is clear. Now, how do I tell the computer ignore white spaces or new lines? Okay. So in that case, you can separate these percentage Ds with just white spaces. Okay. So now, irrespective of the number of spaces you give, number of new lines you give between 2 percentage Ds, it will ignore all of them. It will skip all of them. Okay. You need not know the exact count of white spaces or new lines you will give between 2 inputs. So a single white space between 2 format specifiers, percentage D is format specifier, right? Between 2 format specifiers, a single white space indicates all white space characters. White space characters are single white space, multiple white spaces, tab, new line, all these are considered as white space characters. Okay. So now it will ignore all. So I say 3, space, 4, single space, or next line 5, it will read them properly. It read 3, 4, 5, and the count is 3. Anything, any number, 34, new line, 567, space, or tab, and 430, whatever big number. It read them properly. Okay, fine. Now same thing we have to do when we are reading character by character. Okay, now let me comment this portion of the code. So now what to do? If you want to ignore white spaces and new lines, you put a space before %C. Okay. Similarly here. Now what it does, it's getting a character as input. It's also getting new line as input. It will ignore new line. It will take only the character. Okay. So now let's test this. So G, It printed only 1 or 3. I pressed G and enter, but it did not take enter now. It took only G. Okay. Or suppose if I enter F space H I. Now it took only F H I. It did not take spaces. It did not take new line. It ignored all the white spaces. It ignored all the new lines. I can press new line anytime, any number of times, but it's not taking that as a character. Okay. T Y E. It's taking only that. T space Y space F. Taking only the characters, not spaces, not new lines. Fine. Now I enter Q. Done. Fine. Okay. Fine. This is one example. Now, suppose if I want to modify my program in such a way that when I enter Q, I also want its ASCII value and then to quit. Okay. Right now it's quitting without giving me the ASCII value of Q. But suppose I want to print the ASCII value of Q and then quit. Okay. Then what to do? Then what we do, we just modify the loop a bit. So we use do while loop. Okay. So now what it does, whatever is the input, it first prints its ASCII value and then checks whether it is Q or not. Okay. So this is called a post-test loop. While loop and for loop are called pre-test loops. That is, it tests the condition before it enters the loop. Post-test loop means it enters the loop and then it tests for the condition. Okay. So now, even if you enter Q, it will first enter the loop. It will print its ASCII value and then checks whether this value is Q or not. Okay. Fine. Now, so here I don't need it here. I put, okay. So I scan a character, print its ASCII value, then check whether it is Q or not. Fine. So now let's see. R, it prints, T, it prints, Fy, it prints, Q, it printed the ASCII value and then quit it. Okay, it did both the things which I wanted. Fine. So do while is used particularly when we want the loop to run at least once, even when the condition is false. While loop and for loop, they will not run even once if the condition is false. Okay, do while will run at least once, even if the condition is false, because it's checking the condition after running. As simple as that. Okay. So the second thing is do while. Its syntax is do some block of statements while condition semicolon. Okay. And its flowchart looks like this. Okay. You first enter the body of the loop and then check for the condition. If the condition is true, you again enter the body of the loop and you go on. So the difference between this and this is, here you test the expression and then enter the loop body. But here you first enter the loop body and then test the condition. That's the difference. If it is false, you come out of the loop and execute the next statement. Fine. Okay. Now let's look at the third one. That is for loop. Okay. So for loop is mostly used when you know the exact number of iterations you want to run the loop for. Like he asked, suppose I want to run only 10 times or 100 times. Then you use for loop. It's not that you cannot use while loop. All the loops are equally powerful. Anything you can do in one loop, you can do in the other loop also. It is just that it is more convenient to use for loop when you know the number of times you want to loop beforehand. If you don't know the number of times you want to loop beforehand, it is convenient to use while loop and do while loops. Okay, that's all. It is not like you cannot use a while loop if you know the number of times you want to run, or you cannot use for loop if you don't know the number of times you want to run. Nothing like that. Anything you can do using one loop, you can do using other loop also. It's just a matter of convenience. Fine. Now suppose simply I just want to print numbers 1 to 100. Okay. So first let me write the pseudocode. So pseudocode is first, I say first step is I equal to 1, then print I. Third step, what should I do? Okay, actually here I need to put a condition. If I less than or equal to 100, print I. Okay. Now in third step, what should I do? Right. I increment I. I can increment I using many statements I plus plus, or I can say I equal to I plus 1, or what else? I plus equal to 1. This is shorthand for I equal to I plus 1, or plus plus I. All these are different ways of incrementing I by 1. Okay. Plus plus I and I plus plus will not work if you want to increment I by 2. Then you have to use either this or this. Plus plus I and I plus plus will work only if you want to increment it by 1. Okay. Now, then what to do? Go to step 1 or step 2? Step 2. I don't want to again start from 1, right? Okay. So first I start with 1 and then I print it if it is less than or equal to 100, right? And then I increment it by 1. Again, I go back to step 2 and check if it is less than or equal to 100. If yes, you print it. Again, you increment. Again, you check. Again, you print, and so on. This is the loop. That's it. Now, the same thing. See, this same pseudocode. Now, this pseudocode is not limited to while loop or for loop. It is independent of the syntax. This is a logic. Pseudocode is basically a way of representing our logic. Okay. Now, this same logic can be translated to a while loop, or it can be translated to a for loop or a do while. Anything. Fine. So let me translate it to for loop, and you anyway understood while loop, so you can do it on your own. So if I have to translate it into for loop, first I say for loop. Okay, first let me write the syntax of for loop. For loop has 3 things inside it. First, initialization, and then terminating condition, and then updating condition. Here you need to notice that these 3 conditions are separated using semicolons, not commas. Okay, semicolon is important. If you put comma, it will give a different meaning. It's not error, but it will give a different meaning. Okay. Yeah, and then some block of statements. Okay, and close. Now, one common mistake which students make is they confuse with the sequence of execution of these statements. So they think, okay, first it will initialize the variable to 1 and then check whether it is less than or equal to 100, and then it will update it and then it will print it. No, this is not the sequence in which they are executed. Okay, the correct sequence is it will initialize it, it will check whether it is less than or equal to 100. If it is true, it will enter the body of the loop, it will print I, and then it updates I by doing I plus plus. Okay. Now it will again check after I plus plus, it will again check if the condition is true. If the condition is true, it will enter and execute the body of statements. Then it will update I again. Again, it will check if updated I is satisfying the condition or not. Again, it will enter the loop and so on. So here the direction is after it comes here, it executes this body of the loop and then it updates it and then it again checks. Okay. The direction is not this way. It's not like this and then this and then this. No, this is wrong. It is this direction. It comes here, it goes like this. Okay. So this is something which you need to keep in mind. Fine. Now let's just quickly execute this. So I will explain what I'm doing. First, I'm initializing some variable int I equal to 1, and then I'm checking if I is less than or equal to 100, and then I'm incrementing I plus plus. I'm opening the bracket immediately. Okay. Now you print the value of I. Okay. So first you made I equal to 1. If I is less than or equal to 100, you enter the body of the loop, print I, and then increment I plus plus. Okay. You continue this until I is less than or equal to 100. Done. It printed already. Okay. Now, suppose if I write this statement printf %d \n I, what do you think will be the output? Only I will be printed. But it's %d, right? I is not inside the quotes. It will print 1 to 100 and then 100 again. Okay, number 100 you are saying. Okay. Huh? Last one will be a random number. Why error? Why 112233? Okay, so let's see what it will output. It's giving an error because it doesn't know what I is. I is declared inside the for condition. Okay, so there is something called scope of a variable. It is local scope, global scope, all these things you will learn when we get into functions. Fine. So currently, since you declared this I as int I equal to 1 inside the for condition, this I is visible only inside the for block. Outside the for block, it is not visible. Outside the for loop, it's not visible. If you want it to be visible outside the for block, you declare it before the for loop, and then you initialize it inside the for loop, or you can initialize it before also. You can override it inside the for loop. It doesn't matter. But I should be declared before for loop. Okay. Now this error will not come. Now what will be the value of I in the last statement outside the for loop? Huh? No, I said I is already given a value. It enters the for loop. Once it exits the for loop, what will be the value? Huh? Inside the loop? Yeah, but it's not initialized inside the loop. I can be value can be given inside, but I initialized it outside, so now it's visible outside the loop also. That is the difference. If you write int I equal to 1, it will be visible only inside the loop. If you declare I int I before and then you use I inside the loop, it will be visible outside the loop also. What is the updated value? Huh? Is it 100 or 101? Okay, let's see. Let me modify it. Or not one. Why? In the last step, it goes to the updating step. And then it tests whether I is less than or equal to 100. 101 is not less than or equal to 100. So it will come out of the loop with the value 101. If it is 100, it will still stay in the loop. It will not come out. It will come out only when its value violates the terminating condition, and 100 does not violate the terminating condition. 101 violates the terminating condition. So it comes out with the violating value, that is 101. Okay? In case you're not clear, think some time, you will get it. Okay? Fine. So let's stop here. Let me take attendance.